Hello, my name is Wesley Fisher, and I've been working with a team of engineers consisting of myself, Riley Bishop, Elena Hollingsworth, Brian Mazzoni, and Alex Doom to construct a lab experiment studying aerodynamic forces, particularly drag and lift, using a small wind tunnel we've got in the lab. So aerodynamics has applications largely in the automobile and aerospace industries. If you think about it, if you reduce drag force, you reduce fuel consumption, which in turn is going to save you money, and it's also going to save the environment. So there's a couple of ways we can measure these drag and lift forces experimentally. We can directly measure them using a force gauge, and that's great and it's effective, but if we do it that way, the only thing we're going to get is just those forces. We don't get any more information about what's really going on with the fluid there. Or we can use this other method where we map the pressure distribution. And that does just that. You get more information about what's going on with the fluid. So if you think about, when I say pressure distribution, I mean, when you think about the wind, on a windy day, you walk outside and the air is blowing into your chest. You feel it hit you in the chest, but you don't feel anything hit you in the back. So that's the idea. You feel different amounts of wind on different parts of your body. So we can measure those different pieces and create this pressure distribution from them. So to map this pressure distribution, we got to have some sort of system to take measurements of pressure. So we've created that from scratch, and that includes the hardware components we need and the software. For the hardware, we use National Instruments data acquisition modules and the pressure and temperature sensors and things like that that we need. And all of those things are controlled through software system, which consists of this coding we've written in the LabVIEW program that controls the whole entire data acquisition process through a single user interface. So after we've made the system, another large part of our project was to verify the accuracy of the system and make sure it's going to work out and be effective as a lab experiment. So we're doing this through a variety of ways too. We're performing theoretical calculations to make sure that it's correct. And we're also performing CFD simulations, which is computer models of the same situation that's going on. If you look at the bottom of the screen, you see that picture on the right? That's what that is. And we're also using that force gauge I was talking about earlier to directly measure the drag and lift forces and compare to what we get from the pressure distribution method. So we're doing all of these ways to make sure that they all match up and agree with each other, to make sure they're all accurate. So that's really the point we're at right now in the project. We have built a data acquisition system, we've put everything together, and we're just now starting to test. But as expected, we've run into a couple of issues. And that's what we're trying to work out right now. The pressure distribution we're reading has the right shape. If you look at the bottom of the screen, the picture on the left, the numerical line, the orange one, that's what we expect to see from testing on a cylinder. And that shape is what we see. But the values don't exactly match up with what they're supposed to. So that's what we're trying to figure out right now. But hopefully once we get that figured out, that'll be one step closer to having it done. And once we get it verified that this system is accurate, we're testing these simple shapes right now to make that easier to do. We'll be able to move on to more complex topics, like testing torsional effects on wind turbines, which happens to be a big energy loss, and it's a problem that people are studying. And that's something that we could have students doing at WKU. Right now, we are really just laying the groundwork for future problems like that that WKU students can be solving. And we're really hoping that this experiment will be the first step towards, inspiring students to pursue their interests in this field as we have. Thank you.